We've all been told that the secret to success is to wake up super early, right? But what if that's not just old advice? What if it's biologically just wrong? Today, we're going to dig into the science of when your brain is actually at its best. And honestly, the answer might just make you rethink your entire daily schedule. All right, let's start with a feeling I think we all know way too well, the 9 a.m. zombie. You're sitting in a class or a meeting, and you're trying so hard to pay attention, but your brain just feels like it's full of fog. We've been told forever that this is just us being lazy. But what if it's not about willpower at all? What if it's just biology? I mean, you've had your coffee, you think you slept okay, but your brain is completely stuck in first gear. If that sounds painfully familiar, trust me, you are not alone. And the best part, it turns out it's probably not even your fault. For way too long, we've been trying to force our brains to fit into this rigid, one-size-fits-all schedule. A schedule that was basically designed for factories during the Industrial Revolution, not for learning and creative thinking. But the science is becoming super clear. It makes way more sense to build our days around our brain's natural rhythms. So, what's really going on inside our heads? Well, it all boils down to your brain's internal clock. And this has nothing to do with your habits or how disciplined you are. Nope. This is about your fundamental genetic wiring. The scientific term for this is your chronotype. You can think of it like your body's own personal prime time, a built-in setting that tells you when you're naturally going to feel alert and when you're going to feel sleepy. And because it's literally part of your DNA, you can't fight it with an extra alarm clock or another cup of coffee. Generally speaking, we fall into two big groups, larks and owls. Larks are those classic morning people, the ones who are bright-eyed and ready to go at sunrise. But here's the kicker. The research shows they're actually in the minority. For young adults especially, being an owl, someone who really hits their stride much later in the day, is way, way more common. And this is absolutely crucial. During our teenage years and our early 20s, our internal clocks go through this massive shift, pushing our natural bedtime and wake-up time a full 2 to 3 hours later. This owl phase hits its absolute peak right around age 19. So think about it. For a typical university student's brain, that 9 a.m. class feels like 6 a.m. No wonder it's a struggle. So if 9 a.m. is basically a biological write-off for a huge chunk of the population, then when is the best time to learn? To figure that out, let's look at what a huge study found when it tracked when students were actually at their sharpest. So the first bombshell from the study, for the average student, their brain doesn't even really get into high gear until 11 a.m. or even noon. And from that point on, they hit this long stretch of high performance that lasts well into the evening. But here is where it gets really fascinating, because this whole idea of an average student is kind of misleading, right? We're all wired so differently. So what happens when we stop lumping everyone together and actually break down the data by chronotype? Okay, look at this. This chart is the big aha moment. A standard 9 to 5 schedule is great if you're a lark. It captures their entire peak performance window. But for an owl, it catches maybe 30 minutes of their best brain time. And for the definite owls, who make up a full quarter of the student population, it captures, get this, 0. Their brains don't even properly turn on until the standard workday is already over. The researchers who did this study, they didn't mince words. They basically said that a normal school day or workday is just completely out of sync with the biology of the people it's supposed to be helping. So learning when your brain is actually switched on is a huge deal. But that's only half the puzzle. What you do after you learn something is just as important for making sure that information actually sticks. See, when you sleep, your brain is busy doing this critical job called memory consolidation. It's organizing and cementing everything you learned. And that brings us to the timing of sleep itself. So in this other really cool study, scientists set up a simple but brilliant experiment. They had one group learn something new in the evening and then go to sleep pretty soon after. We'll call them the sleep first group. The other group learned the same stuff in the morning and then went about their normal, busy day, the wake first group. And the results were, wow, crystal clear. After 12 hours passed, the group that went to sleep right after learning remembered way more. Sleep basically acts like a protective shield for new memories, keeping them safe from all the interference of a busy day, where all these new experiences are constantly competing for space in your brain. So the big takeaway here is that sleep plays this incredibly important protective role in learning. By giving your brain some quiet time to sort things out, sleep helps lock in new information. It stops the events of your day from accidentally overriding or messing it up. Okay, so let's put this all together. What does all this research really mean for you and me, for how we should study, how we should learn, and maybe even how we should work? All right, if you take away anything today, let it be this. First, stop beating yourself up for not being a morning person. Your best time to learn is just built into you. Second, those rigid early start schedules, they're failing a massive number of people. For most young adults, starting after 11 a.m. is just scientifically better. And finally, don't just think about when you study. Plan for a good night's sleep right after to make sure all that hard work actually sticks. And that leaves us with this one last really big question. Our schools, our jobs, our whole society is built around a clock that was invented for a different era. But just imagine, what could we all accomplish if we redesigned our world to work with our biology instead of constantly fighting against